I'm Joshua.
And I'm JR.
And we are the Team Gala! So for today's video, we are going to share to you the how light acts as a wave and a particle and experimental evidences and wave property of light. In experimental evidences and wave property of light, wave moves in straight lines like the waves of an ocean, spread out in circles like ripples in a pond, just like some waves in the air. But when wave hits a boundary, it exhibits different properties, such as reflection, refraction, diffraction, and interference.
Reflections occurs when the waves encounter a surface or other's boundary that does not absorb the energy of the radiations and bounces the waves away from the surface.
Refraction is the bending of light. It also happens with sound, water, and other waves as it passes from one transparent substance into other.
Diffraction is a slight bending of light as it passes around the edge of an object.
Interference is the phenomena of multiple light waves interfering with one another under certain circumstances, causing the combined amplitudes of the waves to either increase or decrease.
And now we are going to discuss to you about how light acts as a wave and a particle. First, let's discuss about what is wave. So, a wave is a disturbance that transfers energy through matter or space with little or no associated mass transport. Waves consist of oscillations or vibrations of a physical medium or a field around relatively fixed locations.
And now, let's discuss particle. What is particle? A branch of physics that line with the constitution, properties, and instruction of elementary particles, especially as revised in experiment using particle acceleration.
While this phenomenon shows the wave-like nature of light, is simultaneously demonstrate its particles as big as well as the electrons pass close to the standing wave of light. They hit the light's particles, the photons, as mentioned above. This affects their speed, making them move faster or slower. This change in speed appears as an exchange of energy packets quanta between electrons and photons. The very occurrence of their energy packets shows that the light on the nanowire behaves as a particle.
Light as a particle. The observations of Planck and Einstein contributed to the particle theory of light. Light is a stream of small particles or packets of energy called photons. A photon is a massless particle of electromagnetic radiation that contains one quantum of energy.
The first ever photograph of light was both a particle and wave. Quantum mechanics and tell us that light can behave simultaneously as a particle or a wave. However, there has never been an experiment able to capture both natures of light at the same time. The closest we have come is seeing either wave or particle, but always at different time.
And that's all for today's video. See you! Bye!